All right. So, okay. So please see this one. Okay. So what's this? All right. So everything, probably everything is okay. Uh, there are, yes, I found the 24 practice questions. Okay. But uh, the real exam. So it's not published. It happened last year, 17th of September. So I cannot publish this one, but I can tell you which questions are important or not. Uh, I'm recording this session. I will put this video on my personal channel. You don't worry about the subscribing me. Don't subscribe me. Okay. So this will remove any misunderstandings. So it is just for me easy. I cannot put this video on Canvas. Canvas has got limited space, so we cannot put everything there. Uh, so I see seven multiple choice questions last year and five non-multiple choice questions. It was 105 minutes. Please listen to me. Focus here. But this year it will be 110 minutes. Okay? Yeah? Yeah. Monday. Well, what do you mean? On Monday I'm not here. Say again. No, I don't have. I have my workshop is on Thursdays from 5 to 7. Okay. There are workshops 2 to 4, 4 to 6, and 5 to 7 on Thursdays. There is one on Wednesday, 8 to 10. Yes. Probably 105 minutes last year, seven multiple choice question, five non-multiple choice question, written answer question. So probably around that number, like 12 of them. Probably seven multiple or eight multiple and five or six written answer questions. But I will tell you as I'm okay. So let's do all the quiz questions all together. No, just not together. Just I'm doing it and look at here. Okay. So the first question says that simplify this one. If we finish this one quickly, and if we have time, we will do more activity, more other things as well. So P or Q and negation P equals, can I distribute this one inside bracket, which is equal to P and negation P, or Q and negation P. This is equal to P and negation P is F, or Q and negation P. So this is equal to Q and negation P. So C is correct answer. First of all, please note that P, T, F. Negation P is T, F and T, P and negation P. So T and F is F. F and T, F. So when we have and, both of them must be T to get T. Otherwise, it is F. So that's why it's F. So let's now have a look at here. F A, F, or A. I am writing this one because I'm talking about this one. So F is always F, and we have two scenarios for A, two values, T, F. F or T is T. F or F is F. So this guy, A, T, F, is the same. Okay, so that's why F or A is equal to A. So that's why F or this guy is equal to this guy. Okay, so so this is just warming up. Question 6 of multiple choice question was from this one. So this is quiz 1. This one is quiz 1, Monday version. So we are unable to cover all the versions of the quizzes today. So Monday version, quiz question 1. Definitely Tuesday, Wednesday, Thursday as well. The question is in the same type. So so you probably will have a multiple choice question uh, like this one. Question 2 says that it's in the same region, same thing. Okay. Hello. Would you like to sit there? Yeah. P is true. Q is false. R is false. So P and negation. So from here, negation Q is not. P is true. P or negation Q or R. So P is T and T, negation Q is T, or F. So T and T is T. T or F is T. So the answer is, so that's very bad if you choose C, because any scenario will be value true or false. Uh, would you like to remember this one? T, T, F, F, T, F. It's a good, so you have the right to have a double-sided cheat sheet. T or T is T, T or F T, F or T is T, F or F, F. So maybe if you really do not like this mathematical logic, so you can write these in like with a small font in your cheat sheet. T, T, F, F. So the order always for me is the same. And T is T, and the rest is F. Okay. So any question about this? Yeah. Oh, what is the meaning of this one? A, B, and three dots here, C. This means A and B, then C. And you need to prove that this one will be this guy. Means all of the related columns is T, 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 T. So truth table. So or so I mean A is any scenario here. Any scenario. So like P, if P then Q. Okay. anything. So this means P, Q, and Q, then R. If we do this one, P, this one. Okay? Yeah? Which one? Which one? Yeah. Yes, but the meaning of this structure means this one. Yes. So if something here, if P then Q, so it is, or if P and Q, whatever. So it means for me A. So one of like this one, it's not necessarily just P. A is not a uh core, what's that? Predicate. It's not one predicate logic. Okay. It is a compound predicate logic. It can be complicated things, much more complicated. So here, and so I will combine this A and B. For me, combine means and. A and B, and these three dots means then. But all of the related corresponding column will be T, T, T. So this will be right arrow with double, like this way. Okay, so let's investigate. You need to be patient with these types of questions. P, Q, R, Q, R, if P then Q, Q then R, if P then Q, and Q and R, then R. Okay, it's too much. I need to do a downsize here. P then R. Finally, this P then Q and Q then R. Then if P then R. Turn off your phone. Okay, so look at here. P, P. How many rows? How many rows? 8. P, T, F, F. So Q, T, T, F, F, T, T, F, F. So how about R? Alternatively, T, F, F. Okay, so Q. So what happens to if P then Q? Can you please remember this one? So I don't want to write it. So if this is F, regardless what happens to the values of the Q, it will be T here. So therefore I will, because of here, F, 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 which is the premise assumption here. So I will quickly write T, T, T for this part, if then. If it is T here, then this part should be T as well. So if T, then T is T, F, F. So again, Q, wherever Q is F, I will quickly write here F, T. Okay, so QTRT is T, QTRF is F, QTRT is T, QTRF is F. This extra lines helps me not to be lost. All right, so can we do this one now? And version here. For the and, if both of them T, it is T. F, T, oh no, F, F, T, F, T, T. Please correct me if it's not, something is wrong. If P, then R. If P, then R. So I will quickly write these F's here, P, T, T. Okay, so if T is T, then if R is T, we will write T here. Okay. Now, can I now this one for okay color. So for this part, I will and part here and part here. So for those ones are F. So I will just quickly write T. Okay, so for those parts are T, there should be T, yes. Yes. Okay, T. So this part now T, T, T. Okay. So this means this guy here, you see here, this one, right arrow. Is there any name differentiating these two symbols? Okay. So when this guy is right arrow tautology, so we will write with this symbol. Okay. So this proves this claim here. Okay. I will share the PDF and the recording videos if you miss anything. All right. Is there any question about this? Mid-semester exam is 30%. Sorry about that. Okay. Now, I remind you that you have seen question 1, 2, 3, and 4, 5, 6, 7 in those two videos that I sent through the email via the link. Okay. Now, we see this one, A1 is minus 1 plus 1. 1 minus 1, which is minus 1. This will be 0. This will be 0. So this is only 0. A2 is minus 1 plus 1 over 2. 1 minus 1 over 2, which is minus half 1 over 2. A3 pardon. Yeah, I substituting n with, yeah, hi. N equal 1 here, C. with n equal 1 here and 1, I do substitute n equal 1. Minus 1 plus 1 over 1, 1 minus 1 over 1. So 1 minus 1 over 1. Pardon? So this is 0. I simplify. Rather, uh, yeah, I will. You sit there. Okay, but please focus here. All right. Thank you. 0, 0. A1 is 0. A2 is again n equal to so minus 1 plus 1 over 2, 1 minus 1 over 2, so minus half and half. For C, if I write, I will get minus 1 plus 1 over 3, which will be minus 2 over 3. 1 minus 1 over 3, it will be positive 2 over 3. And AN, I continue until the end, I will get 1 over 1 minus 1 over n. I don't want to simplify this one. So n goes to infinity. If n tends to infinity, then 1 over n tends to 0. But 1 over n never be 0. From here, minus 1 here, it's not 0. Otherwise, an would be minus 1 and 1 with broken bracket. But it's a tiny bit more. So minus 1 will be not included here. So union of an running from 1 to infinity is minus 1 plus 1. Yeah, as you said, part C. This was the question of last year, first question. More or less refined or changed, modified. So, yes? Pardon? Yeah. So an is this part, and n is the, if n goes to infinity because it is an, so infinity here. All right. See, it's n until infinity. So if n tends to infinity, then 1 over n tends to 0. Yeah. It's a limit of 1 over n is 0. Means I can prove it a limit, but the proof will make situation worsen because it will relate it to the epsilon or epsilon m. So this one is this guy. So it goes to, if you divide, roughly speaking, 1 over 1 billion. A billion, how many zeros does it have? 8. So 1 over, it will be a tiny number. Tiny number. So, however, A1, you see that it's a subset of A2, subset of A3. Okay. Okay. So, if you have union of increasing sets, this means your answer will be limit of an. Okay, that's a well-known proposition. If a1, like this one, decreasing by the time intersection of a and n running from 1 to infinity will be an. You don't have to memorize anything. It's just obvious. You can understand this one intuitively. You don't have to prove it. So in the last semester, last year's question, it was like something minus 1 over n. 1 plus 1 over n. So it was like intersection instead of an. Okay, so it was intersection. So the answer was like, yeah, something like this. All right. So the intersection will be here with this situation. It will be smallest number, A1. So if we have this one, increasing set, AN, obviously this guy. And here, decreasing, obviously the biggest guy. Okay. Beg your pardon. Then, so let me understand. You said that so union of AN is, yeah, okay, limit of AN and intersection AN will be the same, yes, but here is decreasing. The set is going small, small, small. Here, getting big gradually. Huh? But where? Quotient? Question, yeah. Minus 1, 1 plus 1 by n. Yeah. Do you want to show me where do let me come there? It's not hard for me. Hard for you. Yeah. How to put a question, you work in our part. So just this part is given to you, not through the brackets. Then yeah. Try to answer the question. Next question. So this was a multiple choice question like last year. Okay. So easy question. A symmetric with B is A union with B minus A intersection with B. Equivalently, A minus B union B minus A. So Venn diagram, the answer is, yeah. So the answer is this one. Last year, not exactly this one, but the question was about finding this part and writing the cardinality of this part. How many elements last year? But now let's do this one here. So A, can I write? So the desired region is this part. Okay, so let's please help me. A is 1, 2, 3. So 2 here, 1 here, 3 here, 4 here. So you see that 1, 2, 3 for A. Okay, so A symmetric difference or exclusive is 4. What's the asymmetric difference cardinality? In case extra question, what's the cardinality of asymmetric B? 2. A minus B. What's A minus B? 2. All right. Okay, it is too easy. I should not explain too much. By induction, prove that if n squared is even, then n is even. Yes, please. Pardon? Yes. How do I write this one? This one? This one? I count the number of elements inside the set. 1, 2. Okay, so this absolute value is like cardinality of the set. Cardinality means the number of the elements in finite set. Pardon? A minus B is this one. Let me count it. Set A, but you need to remove the intersection part, the command part. Okay. Okay. All right. Thanks. A minus B, let's assume let's assume that n, so n squared is even, p, then q is n is even. N is not even by contradiction. So n is odd. This means n is equal to 2k plus 1 for some k belongs to integers. As a result, no, as a result is not true. Consequently, n squared is equal to 2k plus 1 power 2 is 4k squared plus 4k plus 1. From here, 2 times 2k2 plus 2k plus 1. Therefore, n squared is an odd, pardon, yeah, one, one, here, for some k belongs to z. Uh, you were asking that what is this one? Z. Z set integers, the line, extra line. Okay. Okay, so any odd animal, odd integer is in this form. Like, okay. So, uh, so like, what are the odd numbers? 1, -1, -3, so on, 3, 5. So for example, 5 can be written as 2 times 2 plus 1. -7 can be written that 2 minus 3. 2 minus 4, excellent. Plus 1. -8 plus 1 is -7. Okay, so that's why it's so the proposition says that your result n is even, but we say that let's assume that by contradiction because the proof is by contradiction. Let's assume that the result is not true. So we can use this method sometimes if we are unable to use the direct proof. So n is not even. N is not even means is odd. Yeah. So n is odd means n equal to k plus 1. Now let's abuse the situation. So n squared will be 2k plus 1 power 2. So expanding this means 4k squared plus 4k plus 1. So this will be, I will factorize 2 here, 2 times some integer. 2k squared plus 2k is some integer plus 1. So this means n squared is in the form of 2 times some integer plus 1, means n squared is also odd. N squared is odd, which contradicts the assumption of question or proposition question saying saying n squared is an even number. So n, the contradiction assumption is not correct. This means n is even. So maybe you could write more. So this means the contradiction assumption saying that n is odd is wrong or incorrect. So this means n is must be even. Okay. Did you have a chance? Did you have any chance to have a look at your quiz questions before? Okay. So, just quickly saying to you that, all right, I don't want to say anything. I have not seen this question among the questions last year, but I cannot confirm or guarantee that you won't see this one. Please. Okay. So last year there was a question exactly on this. Okay. So let's okay. So question says that with this matrix is this some reflexive. Reflexive means one should have a relation with one. Do we have one relation with it? So means loop. Oh, so one example is enough for us to reject choice A. So there is no loop for 1 or 2 or 3 or 4. So at least one of them doesn't have this one. So part A saying that there are or relation is reflexive is not correct. R is symmetric. Well, 3 has got not 3. 3 has relation with 2, but 2 doesn't have relation with 3. The symmetric means if A has a relation with B, then on the opposite side, the other side should be true as well. R is anti-symmetric. Anti-symmetric means none of them has got two-sided relation. So, but 3 has a relation with 4 and 4 has a relation with 3. This means they must be the same number, but they are not. So all in all, two different elements, they should not have both two like relation with each other, two-sided relation. So part C is not correct. Okay. R is not transitive. Well, 1 has a relation with 3 and 3 has a relation with 4. Why? 1 has a relation with 3, 3 has a relation with 4, but we don't have one relation from 1 to 4. We can find other example, 4 to 3 and 3 to 2, but there is no relation from 4 to 2. So is not transitive, so part D is correct. Choice D is correct. Yes, please. C. Okay, it says that this one. So it says that anti-symmetric or anti-symmetric. So if A has a relation with B and B has a relation with A, then A should be equal to B. But here we have two different. 3 has a relation with 4, 4 has a relation with 3, then 3 has to be equal 4, which is not obvious. So anti-symmetric. Since you guys are interested, okay, let's have a look at here. When he is asking a question, I look at you. The voice is here, the video is here. That the other week I was thinking that something happened to you, so I wanted to see you, so yeah. So then you did not turn up here, so I thought that, but I was thinking the other two students unfortunately passed away. Okay, so happy to see you. Okay. Uh, so I will explain more. Uh, 1, 2, 3, 4. 1, 2, 3. And I'm so sorry if these matter like questions are very easy for it can be kind of ready for you. Okay, so let's change the color maybe. 1 to 1. Is there any relation between 1 to 1 is 0? No. 1 to 3, yes. 1 to 2, yes. So what did I do? 1 to 3, 1. 1 to 2, yes. 1. 1 to 4, no. So okay, 0. Now 2 to anywhere. 3 to 4, 3 to 2. So the rest are 0. 4 to only 3. Okay. So why do we do this? Because we need it. Okay, so can I transitive? I don't know, but actually I should analyze one by one. And to be honest, it's difficult to understand from the figure. So you need to you should inspect detail by detail. A to B, B to C. Is there any A to C? You know, one by one. You should check this one. A has a relation B and B has a relation with C. Is there a relation with C? All one by one, you should check out this. If you find A to C, yes. But here you see that you have got 1 to 3, 3 to R, but this guy is not here. So it's not transitive. Okay, so we need okay. So what about from so if you are not lazy, you can do this. Uh from the first you can draw the adjacency matrix. I expect you guys that you don't have problems of drawing or writing the adjacency matrix. 0. So it's reflexive? No, because the diagonal all must be 1. At least one of them 0, so it's not reflexive. Symmetric? I has to be mirror of here. For example, this one is not same as this one. So it's not symmetric. So part B is not anti-symmetric because of this one. These two, they must be all the elements of the upper triangle and lower triangle, they must be different. Okay, if one of them is 0, the other one should be 1. And here we found something that it's the same, so it is not anti-symmetric. Transitive, we can't understand from here. We need m squared. Yeah, so the non-zero part of the m squared should be the subset of the non-zero part of the m. So m let me write this one. So 1, 1, 0. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0. Okay. So it says that what's the m squared? Did I remove that equation? Okay, so from here, we can understand m. So 0, 0, 1. So the answer is this because of this. So let me see if there is. Okay, so m squared is coming from here. So it is coming in the next question. So let's delete this extra page. All right. So is there any question about this? M now, let's do this one. A. I see A, B, C, D, 4 letters. A to A, 1. A to C, 1. Do I need to do these things cross cross? No, I don't need. But you should have some method for yourself to be conservative. It's not assignment questions. It's mid-semester, and due to a general natural pressure, stress for you, you might make a mistake. So you should better to do these things. So the rest will be 0. B to A, 1. B to D, 1. All right. So the rest are 0. C to C is 1. C to B, 1. So the rest are 0. D to D, 1. D to A, 1. Yeah, like this. So M squared equals M times M. Okay, let's write here. I'm gonna be lazy. Ah, okay, I know what to do. Don't be so happy too much. Okay, so uh, so this will be 4 by 4. Okay, so what's the address of here? 2 times 3. Yeah, this one is, what's this one? For example, row number 2, column number 1. Okay, so what do I do with this one? Well, uh, you see this one coming, first one, for this one, 2 by 1 means second row from the first matrix and first column from the, so in our product of these two. So 1 times 1, 0 times this, 0 times this, 1 times 1. So what's the answer? Okay, don't answer. The answer is 2. 1, 0, 0, 1, dot, 1, 1, 0, 1. So this is times this. 1 times 1 is 1. 0 times 1 is 0. 0 times 0 is 0. 1 times 1 is 1. So the answer is 2. Uh, let's do this part. Uh, again, 2 by 3 is second row, third column. So 1 times 1, 1 times 1, 0, 0 will make it 0 for this. 1 times 0. So it will be, the answer is 1. Okay, so I will do now this one. First one, 1 times 1 is 1. 0 times 1 is 0. 1 times 0. So it is 1. So let's do this one. So this first 2 0 in the column is, it will make it 0. 1 times 1. So the answer is 1. So part. So what's the answer of this one? 2. Answer of this part. What's the answer of this part? X. So, all right, let's do 1 0 0 1. So this part, go. Last one is 1. So 1, 1 is 1. 1 is 1. 1. 1 0 0 1 is 2. 1 0 0 1 with this one. Second column is 0. Third column is 1. Last column, last row, last column, which is the last element, is 1. All right, like this one. So very carefully, so that I hope you won't lose any marks. So unfortunately, this was in the last questions of the 2024. Now, your interested question is here. So I assume that you will do this one couple of times by yourself. So you won't lose. Yeah. So you don't have to say that I'm starting from here. So which one should I do? This one, this one, this one, then this one, this one. No. So write the addresses, the elements, the places which place they live. So according to the numbers, you can get the rows, which row and which column here. Now, usually the GCD of 2, 7, 3, 110 in the other university, we don't have to use Euclidean equation. So I will get which we do write again Euclidean equation, but we use this like we write like this one. So let's write firstly like this. We will choose the small number. Then 273 divided by 110, the remainder is, so two of them, 2 times 110 is 220. Take away from 273, it will be 53. GCD, again, I will choose the smaller number. 110 divided by 53. It is, the quotient is 2 because 2 times 53 is 106. And the remainder is 4. The GCD of 53 divided by 4 is 13. 13 times 4 is 52. 52 taking away from 53, or 53 take away 52. The remainder is 1. From here, it is obviously number GCD 4 divided by 1, the remainder is 0. When you see the remainder, one of the GCD A, B is, if one of them is 0, the other number is the answer, 1. Okay. Let's do in this way. 2, 7, 3. Unfortunately, you will have 2 questions about this. Yes, please. Huh? I will come. Okay. Yes, yes, yes. Okay. So, the next note is, yeah. It's possible to find GCD from several ways. Okay. GCD 273 divided by 110 times 110 plus 53. I am cheating from here. So what happens? So this guy comes here, 110. This comes here, 53. So again, now we have 2 square. There is a reason that I'm writing like this. 110 divided by 53 is 2 of them. So the 4 is this one. So as above, this guy comes here, and 4 comes here without square. Plus 1. And 1 is the GC. Okay. If sorry, 4 times 1, then 1. 4 divided by 1 is 4 plus 0. So the non-zero, the last non-zero number is the GCD. Okay. When you solve the arithmetic number theory equations, so you need to use Euclidean theorem because you eventually you have to write your GCD as the linear combination of those two numbers. So what's the answer here? Is this one? Now we 1, 2, 4, 5, 6 edges. 1, 2, 1, 3, 2, 4, 2, 5, 3, 5. What's that? 3, 5, 4, 4. That's very bad. 4, 5, 5, 6. Says that find the length of the shortest path from vertex 1 to. So for that one, I see that there is one here. And there is one as also like this one. So anyway, from 1 to outside, you need to use one of these. And from to 6, going to 6, there is one road. So 2 roads, at least 2. So this is not the answer. This is not the answer. So it will be 3 or 4. But I can understand that from the green highlight and the yellow highlight, it is just 3. So this is this easy graph to grasp the idea, to find the shortest path in but if you get complicated graph, so you need to use this algorithm. This, I don't know, this should have been in your part of your course material, but it's not. The Dijkstra's algorithm. It's not. If it's not, then you need to learn it. You are a computer scientist. You need to learn it. Okay, so beg your pardon.
It's the number of lines to take
how many edges? The minimum, the lowest number of edges getting from 1 to 6. Okay, so from 1 to 6, how can I go to 6? I can come to here to here. So how many edges did I use here? 1, 2, 3. But it is possible to use this one, 2, 3, 4. But that's not the answer. The shortest. So again, the Dijkstra's algorithm is very good one. M squared, you had a question last year like this one, M squared. So, and there was a question like this one last year in multiple choice. Both of them were multiple choice. Okay, so let's go down. Says that solve this one. Okay, so last year there was a written answer question from like doing this one. I know. So you guys want a calculator because of this? Yes? Yeah. So to solve this one, we do this one, GCD of 35, 56. We need to find this one. Okay, so 56 divided by 35.
I'm sorry, can we just make sure that there is right?
Yes, GCD.
Okay.
We need to find GCD. So to make sure that there is a solution for this one, what type of equations? A, X, B, N, mod N, M has to count B. There is a solution if this happens. Okay. So it says that, so anyway, we need to find the, GCD of A and M has to count B, not M. Okay. Yeah. To make sure that, again, I do repeat that this one, to make sure that there is an answer for this one, there is X for this one, the GCD of 56 and 35, or 7, the right hand side, the 7 has to be divisible by the GCD of the 56 and 35. Okay, 56 divided by 35. Okay, 56 divided by 35 is just 1. 21. Okay, this is coming here. Ah, 1, yes, plus the remainder, 14. This one comes here. One, 7. Zero. Okay, so the GCD is 7, and 7 divisible by 7. Yeah, so there is a solution for this one. 7 divisible by 7. Say again. 56. So this means last non-zero, which is 7, is the GCD of the 56 and 35. Remainder of the 7 when we divide 21 by 14. So 21 long division 14, 2 times this is 1 times 14 is 14. 21 minus 14 is 7. So let's 7. If GCD was, if this 7 was unable to divisible by GCD, then we stop working on it. Like 8, 9. So if this one was 8, we would write like this one. So the GCD is not divisible. The 7, the right hand side of the equation 7 is not divisible by GCD of the 35 and 56. So there is no solution for this one. Thank you very much. Or 7 could be 14 or 21. Whatever it should be, whatever it has to be some animal divisible by 7. Here 7 is divisible by 7, obviously. All right, let's write the GCD as the linear combination of the 56 and 35 with this method, Euclidean. So we use this one. Because of this, 7 is equal to 21 minus 14 equals. Second equation, third equation used, second, 21 minus 14 is equal to, inside round bracket, 35 minus 1 times 21 is just 20. So let's rearrange this one. Minus, I prefer to write the bigger number first. Minus 35 and minus 21 is positive 21. Positive 21 and another 21 here means 221. Yeah. So let's write now minus 35 plus 2 times instead of 21. Can I use this one? This guy. First equation times instead of 21, I will write 56 minus 1 times 35 is just 35. So let's rearrange this one. Minus 35 plus 2 times 56 minus 2 times 35. What I did, just nothing. It's not mathematic here. 2 times minus 35 means this one. So let's rewrite. Again, I prefer to write the bigger number first. 2 times 56 minus 2 times 35 and minus 35. Altogether is minus 3 times 35. Minus 3 times. Okay, so what is the result is, the conclusion is 2 times 56 minus 3 times 35. Now we see that, what was the equation? Equation was 35x7 mod 56. From here, we see that so I prefer always, once we write this one, we will make number alone with its coefficient alone on one side of the equation. So this will be minus 3 times 35 equals to 2 times 56. All I did is just I moved this guy to the other side. That's why they receive a negative, so they need to change the sign. But I prefer to keep like this one to remind you that when we have A minus B equal MQ, means A equals B mod M. Turning off your phone. Now, from here, 7 equals to minus 3 times 35 mod 56. Is there any question about this? From here, you can see that you can commute this one. Minus 3 times 35 equals 7 mod 56. A equals B mod M. And so just remind you that the equation was 35x equals 7 mod 56. From here, can see that x is this guy. So x equals to minus 3 mod 56, or minus 3 plus 56 means 53, plus 56 is 109, plus 56 is 165, and so on. Minus 56 is like minus 59, and so on. I prefer to use the smallest positive number, so x can be also written as 53 mod 56. It is the same as writing x equal minus 3, or x is equal to 53 plus 56k, which is the same answer. So you don't have one unique solution. It's like several answers. Now, here, look at here. Now, let's make up an equation. Huh?
How would
No, we cannot do that.
but the-
It's lecture note. At first, I said that like this one. I was talking about this one, that for this one to find GCD of this guy, you don't have to do this Euclidean method. But I wrote this one because I want you to remember not to confuse here. It is for me, for example, here, you say that if you don't square around this one, you say that, okay, this is a big number, 13 divided by 1. Although that, so there won't be any changes here, probably here, just here, but you should have your own method not to get confused. This is not a different method. It's almost the same thing, only this one. For this,
can you-
Yeah.
That problem.
Yeah.
Questions. Can you just- The one that used the blue pen.
Oh yeah,
So can you get the DCD?
here,
And
GCD by using a theorem saying that GCD of A and B is equal to GCD of the, choose one of them which is smaller, say B. And the other guy is A minus QB. So this guy is R. This is a theorem coming from number theorem. If you are interested, there's a proof for that. I don't remember now. It's not big deal, but it's possible to prove. So everything, even this one, is coming from here, from this theorem. Okay, so let's assume that the answer, the question was like this one, 35x, look at here, listen to me, 14 mod 56. And do you remember that you were able to write the GCD was 7? So since this is like 14 divisible by 7, then it is okay to solve it. So for the Monday version, you don't have this one. When you get GCD 1, it is easy. When you get GCD something like not 1, but it has to be divisible by the right-hand side like this one. But what you do? Well, you got this linear combination of writing this one here. 7, yeah. So let's write 7, 2 times 56. What was that? Minus 3. Minus 3 times 35. Well, in this situation, you should write times it both sides by 2. This one shows the need of the GCD has to be divisible by the right hand. The right hand side 14 has to be divisible by GCD. So this will be 14. This will be 4 times 56. So this one. Okay. So what do I do with this one is, again, I prefer to keep this one alone one side. So this will be 14 minus 6 times 35. Brothers, can you listen to me? Focus here. Okay, from here, 14 equals to minus 6 times 35. mod this guy, 56. So your answer will be x equal minus 6 mod 56. Or minus 6 plus 56 means 50. So it is okay to write 50 mod if it is multiple choice question. Okay. So the other versions of not Monday, maybe in Tuesday or Wednesday, you might have like this scenario. In Thursday one, I remember that it was like the GCD one and it was much easier. But in that scenario as well, when it's GCD one, then you need to times it by the both sides by the right hand side of the equation. Okay. So was this one was the one of the written answer questions of the last year. All right. So the coordinator is interested to the planar equations usually, planar graph. Planar graph means the edges does not cross each other. Like this one, this one, this one. Yeah. So this one, complete graph K4 to might do like this one or this one, but planar means you should not cross unless this one is a vertex. While we know that this is not a vertex. So what do we do? The planar version of this one is like this. Okay. So now says that did we have this question last year? Yes, one of the multiple choice questions was this one. So you need, first of all, you need to remember the Euler's formula, E plus 2, maybe absolute value around that, F or region plus absolute value of the number of the vertices. Okay, so let's discover how many edges do we have here. How do we know the edges? How do we know the number of the edges here? Huh? Yeah, how do we know that the number of the lines? The group brothers over there as well. Hello, on the corner. How do we know edges here?
A plus, I forgot the. But I know there's something plus something is equal to something plus something.
No, sorry. What about, yeah? Yes, we do add up all the degrees, okay? Divided by 2. Okay. Please concentrate here. It's not, so we are going to finish the class. So let's do 2 plus 2 plus 2 plus 3 plus 3. Well, 15, 19, 23, 28. So ages gonna be what? 14. So this, okay. Now let's use the Euler's formula. 14 plus 2 absolute value of mobile phone F plus how many vertices do we have, by the way? That was example. Here, 1, 2, 3, 4, 5, 6, probably 7, 8, 9. And it's written here, by the way. Yes. All right. So 9. So let's find object value of f. So this one is like 16 f plus 9. Yeah, I don't want to solve this one for you. 7. So the answer is this 7. Okay. Ooh. Let's solve this one. It's very hard to solve this one. So isomorphic. So in the Monday, Tuesday, so one you will have definitely one question in non-written written answer questions. You will have one from this guaranteed, and the other one was this number theory. Weeks ago, so week 7 minus 2 is week 5. This one is like until this week is definitely want to it's can confirm that until this week. But for next week, I don't think you will get a question about that. So until this current week, you will have questions. Okay, so from Monday to Tuesday, Thursday, you have this week's lecture. Maybe I'm not sure. I am not sure. I didn't such question last year, but maybe this year the coordinator will change his mind. Yeah, so maybe this year, but definitely until the workshop of this current week, you will have questions. Okay, from Monday to Thursday, there was this question on the quizzes. In some of them, they were isomorphic. Yeah. Maybe I don't remember 10 of them. Each might be 2%, maybe. I don't know. Monday to Thursday, there was this question. In some of them, they were isomorphic. You needed to prove it. In some of them, they were not isomorphic. You needed to give your reason. So there is this one. I see that very quickly. It's not isomorphic. Okay. Why? Because I have degree 2 here, but here I have 2 degree 2. Easy. Yeah. Huh? Yeah. No, we don't have to get attended. It doesn't give any marks to you.